Just like the human brain, AI learns from experience. Here's the big idea. Our brains and artificial networks both build models of the world by forming connections, biological in our case, mathematical in AI. Hey there, and welcome to SkyTech Science, the podcast where we explore the latest breakthroughs shaping our future in science and technology. I'm your host, Hector Duran, and today we're diving into the question, how do artificial neural networks actually work? And to get there, we're starting with babies. Imagine a baby looking at a face. At first, it's just a blur of shapes, but after seeing many faces, parents, siblings, strangers, the baby's brain builds a mental model of what a face looks like. And this model is created by forming thousands of neural connections, linking together patterns like two eyes above a nose, or a mouth that moves when someone talks. This model becomes so refined that, later in life, the brain can recognize a face in milliseconds. Without that model, it would take way more time and brain power to analyze all the visual information, every line, every shadow, every contour. Now here's something you probably noticed. Have you ever asked yourself why it's so hard to recognize faces from ethnic groups different from your own? It's not about prejudice. It's about experience. The face model in your brain is shaped by the kind of faces you've seen the most. If your environment has mostly one ethnic group, your brain becomes an expert at recognizing variation within that group, but not necessarily outside of it. This is called the other race effect, and it's a powerful reminder that what we learn depends on what we're exposed to. Now, here's where it gets interesting. Artificial neural networks are just as dependent on their training data. But what is a neural network? Artificial neural networks, or ANNs, are inspired by this exact brain behavior. They're made up of artificial neurons arranged in layers, and they form internal connections, or weights, just like our neurons do. We feed the network large amounts of data, like thousands of face images, and as it processes that data, it adjusts its internal structure to detect and recognize patterns. The early layers detect basic features like lines and edges. The middle layers piece those together into eyes, noses, and lips. The deeper layers start to see whole faces and differentiate between them. Just like a baby learning to recognize mom from dad, the AI model builds up a set of internal expectations, a face model, based on what it's seen most. If you train an AI model mostly on one ethnic group, guess what happens? It gets really good at identifying faces from that group, and much worse at others. So, just like the human brain, AI learns from experience, and it also inherits the biases of the data it sees. That's why diverse training data is so important in AI, not just for fairness, but for accuracy. Once these models of biological or artificial are built, they allow recognition to happen almost instantly. Your brain doesn't examine each detail of a face from scratch. It checks the input against your internal model, and that takes just milliseconds. Artificial neural networks do the same. They match the data they're given to their own learned models and respond faster than traditional algorithms ever could. Here's the big idea. Our brains and artificial networks both build models of the world by forming connections, biological in our case, mathematical in AI, and what they learn, and how fast they react, depends entirely on what they've been exposed to. That's it for today's episode of SkyTech Science. If this helped you understand neural networks just a little more like real brains, hit follow and share the episode with a fellow curious mind. Until then, I'm Hector Duran, and remember, recognition is learned. And what you learn depends on what you've seen.